Hi, I'm Andrew Connell, and I'm a Microsoft MVP in the area of Microsoft 365 development. And I have a lot of experience with SharePoint development, including all of the different development models that we've had, Microsoft Graph development, Microsoft Teams development, and developing add-ins for Microsoft Office, as well as working with Microsoft Identity, including Azure AD. The Microsoft Identity Platform enables developers to build many different types of applications to satisfy diverse business requirements in different scenarios. By supplying multiple OAuth 2 standard authentication protocols, developers can create different types of applications that meet business needs, including single-page applications, web apps, mobile or native apps, and services or Daemon apps. In this module, we're going to learn how you can implement different OAuth 2 protocol grant types in popular application types, such as single-page applications, web apps that call APIs, and Daemon or service apps. And specifically in this module or in this section, we're going to focus on single-page applications. Web standards in modern browsers have advanced considerably in recent years to the point that web developers can create sophisticated client-side applications. These client-side applications, also referred to as single-page applications or SPAs, can enable users to authenticate and obtain tokens from Microsoft Identity Platform that can be used to call secured APIs. Many modern web applications are built as client-side SPAs written using JavaScript or a single-page app framework, such as Angular or Vue or React. These applications have traditionally used the OAuth 2 implicit flow to authenticate and obtain an access token to connect to protected services. The pattern used to implement the implicit flow in SPAs included the use of iframes and cookies for silent single sign-on in the browser. However, many modern browsers now block third-party cookies, which breaks that implementation. That fact, along with concerns about the visibility of access tokens when using the implicit grant flow, led to the decision to move to using the OAuth 2 authorization code flow for single-page apps as well. The easiest way to use Microsoft Identity for authentication and obtain access tokens to authorize requests to secured endpoints in SPAs is to use the Microsoft Authentication Library for JavaScript, or MSAL.js. MSAL.js v1 only supports the use of the implicit flow. However, in July of 2020, Microsoft released MSAL.js 2.0, which supports the use of authorization code flow. The remainder of this unit and the following exercise is going to focus on using MSAL.js 2 and the use of the authorization code flow. In order for a SPA to use Microsoft Identity to enable users to authenticate and obtain access tokens for use with services such as Microsoft Graph, you must register a new app with Azure AD. You can do this using the Azure AD Admin Center at aad.portal.azure.com. After the application has been created, configure it to use the single-page application platform. Next, ensure that the redirect URI of the app points to the URL of the SPA. This URL must match the redirect URL provided by the SPA when the authentication process is initiated. Now load the MSAL.js 2.0 library from the Microsoft Hosted Content Delivery Network, or CDN. You don't see that here on the slide, but it's just a script reference. After adding the script reference to the page, add the following code that you see here to obtain an instance of the application. The app ID and directory ID tokens in the code are placeholders for values that are going to come from the Azure AD app, and we'll see that when we do the demo in a minute. Now, one thing that's important to take note of here is that the preferred experience when using MSAL when signing in and obtaining access tokens is to use a pop-up window. And that's what we're showing here. However, some browsers have known issues with pop-up windows, and in these cases, you can choose to use MSAL's equivalent methods that will use browser redirects. Now, with the application configured, the next step is for the user to sign in. Do this by calling the login pop-up function and pass in an object with the wanted permissions defined. The code will open a pop-up that loads the Azure AD sign-in experience, and if the user hasn't signed in previously and granted the app the specific permissions, after a successful sign-in, Azure AD will present the user with the consent experience. After completing the sign-in experience, MSAL.js will close the sign-in pop-up and execute the success path of the login pop-up method. After the user has signed in, the next step is obtaining an access token to use in the authorization header of the request. There are two methods on the MSAL.js API that you can use for this task: acquire token silent and acquire token popup. Acquire token silent is used if the user is already signed in and an interactive sign-in is not going to be required. This method is going to return a response that includes the access token. The other method, acquire token popup, this is useful if the previous method, acquire token silent, fails and or an interactive sign-in is required, such as if you need new permissions granted. You can use this method, the acquire token popup. It will combine the request to sign in and obtain an access token all in one step. And then, once your SPA has an access token, you can use it to call a secured endpoint, such as Microsoft Graph. So you see here a function called get messages from Microsoft Graph. We're specifying the endpoint that we want to go to. And then the important piece of this is the second to last line that you see there where it says set the request header. The request header being set is the authorization header with the value of bearer, space, and then the access token. That's going to be sent to authorize us to be able to use our application and to access the Microsoft Graph with our access token. Now in this demo, you're going to see how to create and configure a single page application that uses an Azure AD application to issue an authenticated request to Microsoft Graph using the OAuth 2 authorization code flow. So the first step to do this in a single page application is typically you're going to create a dynamic web application that runs entirely client side in the browser, usually in a single web page. Now to do this, your single page app must be served up as a routable page within a web server, which is what we're going to do from our local developer environment. So the first step usually is to create the web app and the web server for the SPA. But what I'm going to start with is I'm going to take a look at Azure AD first. So what I've done here is I've logged into my Azure portal, which I can get to from aad.portal.azure.com. And if I come over here to Azure Active Directory, and I select the list of all of my applications that I've created, I'm going to find an application that I've created ahead of time called Identity SPA. Now, this is the one that you would create in the exercise. So what this is what you're going to use to obtain an access token and to register an app to have permissions to talk to the Microsoft Graph. So what I would do is I would first go in and let's just jump back real quick. What I would do is go to App Registrations and click New Registration. But let's look at the one that I've already created here. When I created this application, I gave it a name of Identity SPA. And some of the other things that I set up here under the authentication piece is that I went and I clicked on Add a Platform and I selected I wanted to do a single page application. Now when I did that, I specified a redirect URI of the URL of where my application lives. Now this URL is what I'm using in development. If I was switching this over to production, I would want to come back and actually update this value to point to my routable endpoint. This is where the user is going to be redirected to after they sign in. So I've set this value right here. Now the important thing that we're going to need from this, once we've created our application, and I'm going to come over here to the overview, and you see here that I've got an application ID, or it's also known as a client ID, and a directory ID, which is also known as my tenant ID. Let's go ahead and switch over to my application. I'm going to go ahead and grab the client ID because I know I'm going to need this in just a minute. So here's my web application. So on my web application, let's take a look at a few things that we've done. I first have added in a reference to this Bluebird library. And what this is a very popular Promise implementation. This is great to use for browsers that don't have a version of JavaScript that's supported, that supports promises, which are useful for making asynchronous requests. So I've gone ahead and added that here to make my life a little bit easier. I've also added in a reference to the MSAL.js v2 implementation, and this is what we need to use to call the Azure AD to obtain an access token. So the first thing we have here is I've got this sign-in button that's going to call a function called sign-in, and then I've got a place where I'm going to display my messages. Now in this sample, what we're going to do is we're going to grab all of the most recent email addresses or emails that my user that signed in has received. So what I've done is I've defined a configuration object. And in my configuration object, I'm going to specify a few things. Where's the redirect URI for my application? This has to match the redirect URI that I entered in for the Azure AD app. I need to specify the client ID. Well, we copied that just a minute ago, so I'll put that in right here. And then I need to specify the authority. Now, the authority is, this is the tenant ID of my application. So what I need to do here is I need to specify the endpoint for where someone is going to log in and what the authority is that we trust for issuing the access tokens. So that's going to be https login.microsoftonline.com/ and then I need the ID of my tenant. So if I come back to my application or to my web app, my browser, I go to the application and I can look at my tenant ID. So I'm going to go ahead and copy that ID out. I'm going to paste that into my authority, right? Now, if we look at the rest of the code here and look at what this does, that's all we had to do to get this to work. I've got my graph configuration object. All this is really just I'm passing in the endpoint that we want to go to and the permissions that we're going to need access to. I'm then using msal.js to create a new instance of a public client application using the configuration object that we passed in. I then am going to start with a username of nothing, and I'm going to also set up my login type. So this is checking to see, am I currently using Internet Explorer? And if I am, then I need to do a redirect login. So remember earlier, I said that the pop-up is the ideal way of doing authentication, but some browsers don't support that. For example, like Internet Explorer. So what we're doing here is I'm going to set it up to where we're going to do a redirect instead of a pop-up. Otherwise, if we're using a different kind of browser, like the latest version of Edge, then we will use the pop-up option. I then have this handler here for handling a redirect. And then I also have a function here for updating the user interface when we actually get our request, and then also how to acquire the token and get all the emails. So let's see what happens here when I acquire a token and getting emails. So from this, I'm going to look at my graph configuration object and get the request object. So if you recall, that request object is the one that contains all of the properties or the permissions, which are also known as scopes, that we'll need access to. So I have my request object. I'm specifying the account that we want to use to log in equal to the account of the user that just logged in. So I went to my msal application and used their sign in. Now, in this case, we haven't signed in yet. We'll see that in a minute, but I just wanted you to see what that looked like. Then over here, I'm going to say I'm going to acquire a token silently. So we're going to try to get a token silently. That's the ideal way of doing this. If that fails, which you can see here in the catch, we're ultimately going to come down and we're going to use the pop-up request to try and log in. But if the login type is not pop-up, we're going to use a redirect option instead. And so from here, with that request that's coming in, we're passing the request in, when I acquire the token redirect, it's going to pass that request in, which will handle the response. And then same here, when I acquire the token pop-up, it's handling that request in as well. And when that finishes, I'm going to get the token response that's going to give me, it's going to have the access token in it and the callback for where I want to call for when this graph request completed. So now, scroll down a bit farther. Here is where we are going to go get the messages from Microsoft Graph. And we saw this code in the slides a minute ago, so I'm not going to spend too much time on it here. Then we have our Graph API callback. So what does this do? Well, what this is doing is this is my callback function. When it gets some data, which is all the email messages, what I'm going to do is I'm going to walk through all the email messages I get back and just write out a bunch of list items and then add those to an unordered list that we're going to add to the div on the page to where we can display all of our messages. And then finally, the important part is down here on the sign-in process. So what happens on the sign-in? Well, we're checking to see what the login type is. Remember, this was defined up above where we were checking to see if we're using Internet Explorer. If we are not using Internet Explorer, then we can do the login pop-up option where we're going to pass in the graph request object. And then when we get our response back, we'll call our handle response handler. And that's the one that is going to ultimately call the process of calling the graph to get our email messages and updating the display. Otherwise, I'm going to do the exact same here on login redirect, and when that completes, that will get the request coming back from a post request, and it will know how to handle that and process the response. All right, so let's take a look at this in action. All right, so now our application is now running. So let me go back to the browser, and let's open up HTTP localhost 3007. All right, so here's our web application. So we're not currently signed in. When I click sign in, it's going to sign me in as the current user. So I'm signed in as Megan. I was already signed in as Megan, and because I've already used in this application, it didn't prompt me for the authentication, for the interactive authentication request. Had I not already been signed in, it would have prompted me to grant permissions to this application. And then once that happened, I would then come back to my web app, and you can see here, it's getting a list of all of my emails that I've recently received. It's a test account, so that's why you see the same email over and over. It's because we've been getting that My Analytics and the Identity Protection Weekly Digest. We get that every week. So these are the last 10 or so emails that I've received. So in this demo, what you saw was how to create and configure a single page application that uses an Azure AD app to issue an authenticated request to Microsoft Graph using the OAuth 2 authorization code flow. One type of the permissions supported by the Microsoft Identity Platform is the delegated permission, which is also referred to as the on behalf permission. Delegated permissions are granted by a user or an administrator to an app to allow the app to act on behalf of a specified user. That's what we're going to look at in this section. So in this section, we're going to learn how to request delegated permissions to enable users to grant them to an application with either static consent or dynamic consent. The Microsoft Identity Platform supports two types of permissions: delegated permissions and application permissions. Delegated permissions are used by apps that have a signed-in user present, and for these apps, either the user or an administrator consents to these permissions that the app requests, and the app is delegated permission to act on behalf of the signed-in user when making calls to the target resource. Some delegated permissions can be consented to by non-administrative users, but some higher privileged permissions require administrator consent. And for example, a user can grant an app the delegated permissions user.read that enables the user of the app to sign in and read this user's profile, and user.readbasic.all. That allows the user of the app to read basic profile information about all users within the organization. Now, only an administrator can grant the user.read.all permission that allows the user of the app to read the full profile information of all users in the organization. And if the user has not previously granted the permission to the app, or the administrator hasn't consented on behalf of all the users in the organization, when a user signs in to an app, they're then prompted with the consent dialog like you see here on the slide. When a user selects the accept button, the consent settings are saved and the user won't be prompted again. There are two ways to define the permissions an app needs that drives what permissions are listed in the consent dialog. These two approaches are called static and dynamic consent. Now, with static consent, the permissions are defined in the app's registration within the Azure AD Admin Center. The static consent approach is how Microsoft Identity 1.0 authorized endpoint used to work, or it still works. All permissions in an application needed to be specified ahead of time, and when users signed in, they would have to consent to all of the permission requests. This approach also enables an administrator to consent on behalf of all users within the organization today. Now, for developers migrating apps from the Microsoft Identity v1 endpoint to the v2 endpoint, Microsoft introduced something called the default scope. This is a built-in scope for every application that refers to the static list of permissions configured on the application registration. The scope of this default functionality is the same as in v1 endpoints, and the scope requests an access token with the scopes on a Microsoft Graph or whatever resource that has been granted to, that the application is registered within the Azure AD admin portal. The .default scope should be used with apps that use the OAuth 2 client credentials flow. And you do this by putting the app ID in the scope. You put the app ID / .default. The other option to static consent is called dynamic consent. And this was introduced in the Microsoft Identity v2 endpoint. With this option, permissions don't need to be specified in the app registration in the Azure AD Admin Center. Each time an app requests an access token, it specifies the permissions it needs in the scope property. If the user hasn't already consented to these permissions, they'll go through the consent experience for the additional permissions. Dynamic consent enables developers to only ask users for the permissions the app needs at that time. For example, at sign-in, the app can request minimal profile information, but later request additional permissions to do more advanced tasks. Now in this section, you're going to learn how to create a server-side web app that will allow users to sign in and grant the app permission to act on the user's behalf. And once the user has authenticated and granted the app consent to act on their behalf, the web app will use data returned from Microsoft Graph by using the OAuth 2 auth code grant flow. So specifically in this section, we're going to look at the web apps that call APIs, including the authorization code grant flow for OAuth 2, the Azure AD app registration, the MSAL code and configuration, the sign-in and how to obtain an access token, and how to call APIs. So in this first section, we're going to look at the web apps that sign in and call web APIs. Adding authentication enables your web app to access limited profile information and customize the experience offered to your end users. Web apps authenticate a user in a web browser, and in this scenario, the web application directs the user to sign in to Microsoft Identity. Microsoft Identity then returns a sign-in response through the user's browser, which contains claims tokens about the user in an identity token. As a second phase, you can also enable your application to call web APIs on behalf of the signed-in user. The OAuth 2 authorization code grant flow is common when websites or custom apps leverage Azure AD as a federated authentication provider. When the application needs a user to sign in or it needs an access token to act on their behalf, it redirects the user over to Azure AD's authorization endpoint to authenticate. The user signs in using their email and password, and in turn, Azure AD redirects the user upon successful sign-in back to a specific URL within the app. When the Azure AD redirects the user back to the web app, it includes an authorization code. The authorization code is an encoded string that only Azure AD can read. The web app takes this authorization code, which is valid for a very short amount of time, and includes it in a request to the Azure AD token endpoint. And in addition, to the authorization code, the request to the token endpoint includes a grant type parameter that tells the endpoint it's exchanging the authorization code to obtain an access token on your behalf. The benefit of this grant flow is that the web app never sees your username or password. All the authentication happens over on Azure AD, and the application just gets the authorization code that's a result of the sign-in process. This aspect of the auth code grant flow makes it very secure. In order for a web app to use Microsoft Identity to enable users to authenticate and obtain an access token for use with services such as Microsoft Graph, you must register a new app with Azure AD, and this can be done in the Azure AD Admin Center. When registering the app in Azure AD, ensure that the redirect URI of the app points to the callback URI of the web app. This URL must match the redirect URL provided by the app when the authentication process is started. The authorization code will be sent to this endpoint, which means that you need to configure any authentication libraries and/or middleware to listen on this endpoint to receive the authorization code. A sign-out URL should also be specified so that the authentication libraries and/or middleware deletes any cache tokens or other data that are only needed for signed-in users. The web app will also need a client secret to sign in with Azure AD to exchange the authorization code for an access token. There are three things that you'll need from Azure AD app registration: the tenant ID, which is the ID of your Azure AD directory, a client ID, which is unique in an auto-generated ID for the app that is also referred to as the app ID, and a client secret that you generated during the app registration. But in a production app, Microsoft would recommend that you use a certificate instead of using a client secret and pull it from something, say, the Azure Key Vault. The web app startup process to configure the support for signing in Azure AD and obtaining an Azure AD, an app ID token, is the next step. In an ASP.NET Core web app, add code to the configure services method that will complete the Azure AD configuration by doing some of the following steps. Set the authority for Azure AD to be the OAuth to Azure AD endpoint. Request both an authorization code and an ID token when a user signs in, and associate the username's property in ASP.NET to the preferred username claim returned in the token. And then finally, you're also going to create a callback when the authorization code is received to add all claims from the ID token to the current signed in user's claims. The sign-in process is handled by redirecting the user to the Azure AD sign-in page, and this is set by default for you when you create a new ASP.NET Core web app. The sign-in process uses values from the app settings.json file and the configuration defined in the previous setup to create the Azure AD URL to send the user to for sign-in. This URL specifies things like the Azure AD applications ID, the tenant ID, and the scopes required by the web application. When a user signs in to Azure AD and is redirected back to the web application, the web app can use the msal.net library to obtain access tokens. The account is retrieved from the currently signed in user, and the token can then be used to call a secured endpoint. The last part of the process is to use the access token to issue a request to a secured endpoint. One way to do this is to create an instance of the Microsoft Graph client and add it as a singleton to an ASP.NET Core's dependency injection system. The instance of the service can then be used from a controller within the web application. In this demo, we're going to learn how to create a server-side web app that allows users to sign in and grant the app permissions to act on the user's behalf. Once the user has authenticated and granted the app consent to act on their behalf, the web app will use the data that's returned from the Microsoft Graph by using the OAuth to auth code grant flow to obtain an access token. So what I have is a web app or an ASP.NET Core web application that I've created previously. If you want to see the steps of how to create this, there is a lab exercise associated with this module that walks you through all of the steps to do this. Now, before we get started with this, the one thing I want you to take notice of is that we have this app settings section, and what this is going to be used for here is to define the different settings we're going to use for the application. So before we do go start walking through the code for this, we should probably go create our Azure AD application because that is something that we're going to need in order to have our web app actually work. So what I'm going to do is I'm going to go ahead and launch a browser in private mode, and we're going to log into the Azure AD portal. So I'm going to log in as an administrator who's got access to create a new app. And we're going to go create a new app. So I'm going to select Azure AD from the left-hand menu, and then select App Registrations, and then select New to create a new app registration. So we'll call this our Identity Web App. Now in this case here, you see that I'm going to use a single tenant web app in this case. So I'm just going to leave it as is, and we'll go ahead and select Register. So here we've got our app ID and our directory ID. So let's go ahead and grab these values. So I'll grab the directory ID, and we'll come back over to our web app, and I'll put that in the tenant ID. Tenant ID and directory ID are somewhat synonymous. I'm going to grab our application ID, and I'll do the same thing for the client ID that you see here. The domain, I'll grab that as well. So let's come back over to our app. And the domain, you can get that if you go to the root of your Azure AD, you'll find it listed right here at the bottom. So I'll go ahead and select this. You can also get it from a properties panel as well. but I'll just grab it from this and we'll come back over to here into our app settings and I'll go ahead and paste that in. So another thing we're going to need is our client secret. So I'm going to come back over to Azure AD and let's come over here into our app registrations. Let's go to the app we just created and let's create a secret. So I'll come over here to certificates and secrets. I'll create a new client certificate and we'll just call this a temp certificate. That's good for a year. And let's grab the value that was created. We need to grab that now because it will only be shown one time. It'll never be shown again. So I'll save my changes. What you'll see if I come back over to Azure AD, if I leave the page and then come back to our client certificates, you can see here that the client certificate is not being shown, so I can't see what it is again. I'd have to create a brand new one if I wanted to create another instance of that. Now the next thing we need to do is need to set up some redirect URIs. And what this is, if I come over here to our authentication tab, what redirect URIs are is that when the app goes to log in, it's going to tell Azure AD that once the user authenticates, where to send them back to. And I need to give it a list of allowed URLs that it can support. And this is just an extra security feature to keep someone from saying, go log in and send them in a different direction. So these have to match whatever I end up using in when I configure my application. So I'll go ahead and say localhost 3007. We'll do that for this one. And then we're also going to use our /signin.oidc. And what that is the OpenID Connect, the Owen middleware that ASP.NET uses. And it has this special URL that it's going to be listening on. So I'm going to go ahead and grab that value as well. And then I'm going to scroll down here under the advanced settings and have a logout URL because we also have a sign in and we have a sign out URL. We have two URLs set here. So I'll go ahead and save these changes. Okay, so we have those, all of those values are now set. And if I go back over here to my app, you'll see that I even have the callback path is set to this sign in OIDC, which is going to take us back to the root of the current URL of the application. So another thing I'm going to do is come over here into our launch settings, and I'm going to make sure that the application URL and SSL port are both set to 3007 because that's what we said it was going to be listening on for our application to listen to on that port. So now let's see how this application works. So one of the things that I've done is let's just jump straight to the actual code and see where this is being used. Over here in the user controller, all I want to do is I want to use the Microsoft Graph to get the current user's name from their me endpoint, and I'm going to display that on the page. So here's a request where we're making that request. So I'm using the ASP.NET dependency injection to have it inject in a graph service client. We'll see where that gets configured in just a minute. Now there's lots of ways to do this, just showing you how we've done it here in this case. Here, when you go to the user controller, the default view, notice you have to be authenticated. The default view is first going to go create a request, and it's going to get the actual request message. And we need that because we need to get the current user that is logged in. So I'm going to grab the current logged in user and I'm going to add him to the property bag for the current HTTP request. And when I use the graph client, I'm going to send the request into the HTTP provider. And then I'm going to issue the request, which is, I have my request right here that I've defined with my handler. So I'm going to say handler.handle the response for a user object that I'm going to get back. And that's my response. So here's my object, or that's the response that you see that I defined up here on line 26. That's tied to the actual request. I get the user back and I'm going to go add them to the view. And then if I take a look at the view for that controller, it's just really straightforward. I'm just going to use the model and grab the display name out because the model is the actual user object. So I'm just grabbing the display name out from that user. All right, so the interesting part here that we need to look at is everything is going to be inside of this startup.cs file. And what this startup file is this is going to run when the application loads to be able to work with and configure the authentication to use Azure AD and the OpenID Connect and MSAL libraries to handle all the authentication. So here by default, when I created the app, I said we're using single auth, which is tied to Azure AD. So it set this up as adding the authentication equal to the Azure AD authentication scheme. And then it's going to pass in all of the Azure AD options that are defined inside of app settings. And so if you see here back at app settings.json, we have Azure AD, and we've told it all the stuff about Azure AD and our Azure AD app that we registered. So once that's been set up, I'm now going to go define the different permissions that we need. So we need the permission of offline access and user.read. So now I need to go get a reference to these app settings. And so what I did is I created an object here called the Azure AD options. And then I'm doing a configuration.bind, specifying the Azure AD option here and passing in all of the different settings. Now the next thing that we're going to do is we're going to create an instance of an MSAL client, a confidential client. And what this is a confidential client is one where I can use a username or an app ID, an app secret, or certificate to authenticate the application. And so here I'm creating a new instance of that. So using this ID for my Azure AD app, I'm defining the authority, which is the endpoint we're going to log in with. And I'm saying we're going to use the v2 endpoint for Azure AD. The redirect URI is equal to my current URL of my site, which is 5001. That was defined in my local settings. And I'm specifying the callback path, which if you recall, that's that OpenID Connect sign-in middleware endpoint is what we're putting on the end of that. I'm also saying I'm going to be authenticating using a client secret, and then I'm going to build out the confidential client. Now, the next thing we need to do is I'm also going to create an instance of the Microsoft Graph client. And so here I'm creating a new Graph service client, and I'm passing in a delegated authentication provider. Now, this right here is going to have the HTTP request passed in, and we saw that from the user controller when that was being passed in when we have a request. I'm going to use that request that was passed in to get that user object out to create an instance of a Graph user account. That Graph user account is going to be used here. So when I say the confidential client acquire token silently, because the user will have already been logged in at this point, you'll see why in just a minute, that here they're going to go to, I'm passing in the scopes for what permissions I'm going to need inside of the access token. And then I'm also going to be passing in the Graph user account as well. And then say, go ahead and execute that asynchronously. And then when there's a request, I'm going to add to the header an authorization header value with bearer and then the value of the actual access token. And that's where I'm going to add in the now configured Graph service client. I'm going to add it down to the as a singleton to the app. Now, let's take a look at this configure section here. So there's a whole bunch of stuff in here in this configure section that has mostly been set up for you. And what this is that it's configuring the OpenID Connect middleware to tell it how I want to handle the authentication with Azure AD. So in here you can see that when there's a request, I'm looking for a code ID and a code and an ID token. So code is the authorization code using the auth code flow, and the ID token is what you also get with the authorization code that's got some identity information about the current user. I'm also specifying the permissions that we're looking for. We defined those earlier, but this is where I want this to happen prior to we're doing all the Graph stuff, right, that we saw earlier, because this is the part where they're logging in. The Graph stuff we saw a minute ago, that happens after they've already logged in, where I'm going to go get an access token and configure the Graph client. In this case here on the token validation parameters, I want to set the name claim type equal to the claim that comes in as the preferred username. So I'm specifying when you get an ID token back, that property on the ID token or that claim for a preferred username, that's the name that I want to use for the current user. I'm going to specify also when an authorization code is received, we're going to have this handler that's going to be defined. You can see down here where that's actually going to run. I'm going to take the handler, pass in a context, and I'm going to await, configure and await to say I want to wait for this to go ahead and authenticate. A little bit farther down, when I get an authorization code back, it's going to pass in the context. I'm going to redeem the authorization code, and then I'm also going to go in and grab the current user and I'm going to add in the claims that we got back from that authentication to the current user's identity. And then I'm also going to say, let's go get a token with the authorization code. And that's where I'm specifying in all the permissions, and I'm specifying in the authorization code that we got back to get an access token over here. All right, so now let's take a look and see how this thing works. So I'm going to come back to our application, and I'm going to say .NET run. That's going to spin up our ASP.NET Core application. And we're going to navigate to the URL that's defined. So let's come over here to our app. So now let's come over to our web app and let's actually go load our application. So I haven't trusted the dev cert. That's not a big deal in this case here on my local machine. And our application is immediately asking me to go ahead and log in. So what I'm going to do is I'll come over here and we'll log in as Megan B. Oh, don't need the @ sign there. And then we'll put in Megan's password. And what we're seeing here is an error that says an unsupported response type, and it says the response type of an ID token is not enabled for the app. So this is actually a very easy fix here, and it's just one I wanted to show you what happens when you run into this. Let's go back to our Azure AD application, and let's log in as an administrator. And there's one step that we didn't do. Remember, we're asking for an ID token. That is not something that is normally returned back. We have to tell Azure AD that we do support it when it's requested. So let's find that app that we created. Here's our web app right here. And let's go to the authentication tab. And if I scroll down, you'll see this section here where it talks about the ID tokens. So I want to select this to say that we will return an ID token back with this implicit grant. So I'm going to go ahead and save my changes, and let's kill the browser and let's start this login process again. So I'll log in again to HTTPS localhost 5001, and let's try and log in again with Megan. So I'll do Megan B. Oh, that's not right. There we go. And we'll put Megan's password in. Now, here it's asking us, saying that it's asking for some information about from Megan. It's saying that you've never logged into this app before and no one's consented for you. So in order for you to use this app, or in other words, in order for this app to be able to get stuff on behalf of you, to get information on behalf of you, you have to consent to this app, consent to these permission requests. So I'm specifying in these two permissions: maintain and access data that you've given it access to, and sign in and read your profile. And those are both defined during the sign-in process because I defined those two permission scopes as things that this app needs. So what I'm going to do is come back over here and I'll click accept. And now if I go over to my user controller, you can see here where it's actually reporting back the current user, which is Megan Bowen, because Megan Bowen, her name is coming from the Microsoft Graph request that we made. So in this demonstration, you saw how to create a server-side web app that allows users to sign in and grant the app permissions to act on that user's behalf. And in this case, it was to act on Megan's behalf to go request information about her from the Graph Me endpoint, the Microsoft Graph Me endpoint. And once Megan authenticated and granted the app consent to act on their behalf, the web app is going to use the information returned from Microsoft Graph, and it's doing that by making a call to Graph, and it's able to do that because it's able to get an access token because we employed the OAuth 2 auth code grant flow. In this section, you're going to learn how to create apps that obtain tokens without user interaction that can either act on behalf of a user to do tasks as the app's identity. So we're specifically going to focus on daemon or service apps that deal with the OAuth 2 client credential flow and what the app registration, the MSAL code, the configuration, and the sign-in process looks like to call and obtain an access token. So in this section, we're first going to look at the daemon and non-interactive apps. Your application can acquire a token to call a web API on behalf of itself, not on behalf of a user. And this scenario is typically used when an app needs an access token but doesn't want to work under the context of a user plus app permission, and instead the app needs its own permission to work independently of a user. These types of permissions are called application permissions. Application permissions are common in a service or Daemon related apps. The way this works is that the application has its own credentials that are used to authenticate and obtain an access token from a token issuer. Here are some of the examples of use cases for Daemon apps. Web apps that are used to provision or administer users or do a batch process in a directory. Desktop applications such as Windows services on Windows or a Daemon process on Linux. These would do batch jobs or an operating system service running in the background. Web APIs that need to manipulate directories, not for specific users. In another common case where a non-Daemon applications use the client credentials flow is when they need elevated privileges that a user doesn't have. For example, even when apps can act on behalf of users, they need to access a web API or a resource with their identity and not the user's identity, such as accessing secrets in Azure Key Vault or an Azure SQL database for a cache. Applications that require a token for their own identities, these are confidential client applications. These apps are given that they access resources independently of a user, they need to prove their identity. They're also rather sensitive apps, which they need to be approved by the Azure Active Directory tenant admins. Having registered a secret, an application password or certificate with Azure AD is another characteristic of these kind of apps. And this secret is then passed during the call to Azure AD to obtain a token. Now, in order for a service or a Daemon app to use Microsoft Identity to enable users to authenticate and obtain access tokens for use with services such as Microsoft Graph, you must register a new app with Azure AD. This can be done using the Azure AD Admin Center. Unlike the previous examples covered in this module, you don't need to specify a redirect URI or a sign-out URI. In addition, you don't need to enable an ID token or an access token for the implicit grant flow. These don't apply to the client credentials grant flow. One unique aspect to apps that use client credentials grant flow is that their permissions must be defined ahead of time. These are also referred to as static permissions. Daemon applications can only request application permissions to APIs, not delegated permissions. App permissions are defined in the API permission page for the application registration in the Azure AD Admin Center. Daemon apps are required to have a tenant admin pre-consent to the application calling the web API, and this consent is provided in the same API permission page. Now, the configuration of an app that leverages the client credentials flow is similar to a web app or a console app. You're first going to create an instance of the confidential client using the Microsoft Authentication library, MSAL library. And in this case here, you can see I'm doing it either with a secret or with a certificate. Now, note that the scope specified when requesting an access token. In other scenarios, the code specified has the exact permission the application needs. But the scope to request for a client credential flow is the app ID followed by the .default endpoint. This tells Azure AD to use the application level permissions declared statically during the application registration process. Finally, you can use the configured confidential client to call a secured endpoint, such as Microsoft Graph. Now, when using Microsoft Graph .NET SDK, first create an instance of the MSAL authentication provider, and then use the MSAL authentication provider in creating a new instance of the Graph Service Client from the Microsoft Graph .NET SDK. And then finally, use the Graph Service Client to submit your request to Microsoft Graph. In this demo, we're going to learn about application permissions and how to define them and how to grant them using a different type of consent flow within your applications. So the first thing we're going to do is we're going to go ahead and create a brand new Azure AD application. So I'm inside of my Azure AD Admin Center. I'm going to come over here and I'm going to create a brand new app registration. So I'm going to go ahead and select new registration, and this one's going to be called the Identity Daemon. Now for this one, he's going to be a single tenant, and because he's going to have a non-interactive login, we don't really care what the redirect URI is. It's not really going to apply here. So go ahead and select register, and it's going to create the app. Now we've got our application ID and our tenant ID. We're going to come back and grab those in a few minutes. We don't need them right now. But instead, what I am going to do is I'm going to come over here to our authentication tab. And what I'm going to do is I'm going to select this suggested redirect URIs for public clients. So a public client differs from a confidential client. A confidential client can have both his ID and secret be secured, whereas a public client, it's not necessarily. So I'm not going to have that redirect URI. And in this case here, what I'm going to do is I'm going to select this first option here as the MSAL suggested redirect. In addition, one of the ways that we're going to have our user log in is they're going to log in with this public client. And so what I have to do is I have to manually turn this on to say that this is okay, because we're using a flow called the resource owner password credential. And effectively, we're simply just asking the user for their username and password, and we're logging in on their behalf. It's not the best option. It is an option, and it's just working for this demo. Instead, you might want to look at other options when you create an application for production that maybe is using something called the device code flow is a better option for you. But we're going to keep things simple and just use the resource owner password credential in this case. So I'll go ahead and save my changes. And now the next thing that I'm going to do is I'm going to go ahead and create a new application permission. So what I'm going to do is come over here to API permissions, and I'm going to go add a brand new permission. It's going to be for the Microsoft Graph. So I'm going to select application permissions. And in this case here, we're going to get all the mail for a particular user. So I'll go ahead and select mail.read and then select add permissions. Now in a previous demo, you saw me use the admin consent endpoint, and you also saw me use the application logging in as an administrator and then having that administrator get that extra checkbox when they go to consent to say, do they want to consent for everybody in the tenant? So in this case here, what I'm going to do is you can see here that this requires an administrative consent, and it shows it's not currently granted for Contoso. So what I can do is this button what I can do here is I have this button here that eventually will display. And what I'm going to do with this is going to trigger the admin consent endpoint to show up. So if I go select grant admin consent, you can see there that it's actually taking me to the admin consent endpoint that we were looking at earlier in a previous demo. So go ahead and select that. And now it's going to ask me to go ahead and do an administrative consent. So I'll go ahead and select accept. And what we should see is in a moment, it'll grant that permission consent, and the status will show that that consent has now been granted for this application. There we go. So now we can see it, but both these permissions have now been granted. So now what I need to do is the next thing that we'll do is I need to create I need to go update our application. So if I go back, we take a look at our application. This is a .NET Console application, and I've got a few configuration settings that we're going to have to set up here that are going to be all loaded and initialized. So what I'm going to do is I'm going to come back over here to our app settings.json, and we got a few settings that we need to specify, like the tenant ID and the application ID. So let's go grab those first. So let's go back to our application. So we know we need the tenant ID, so I'll copy that. I'll put that right here. I need the application ID, so I'll grab that as well. I have to also create a secret. So the secret, I'll go ahead and let's go back over here to certificates and secrets. And in production, you probably want to create a real certificate and use that. But I'm going to create a secret here just to make things simple for my demo. So I'll just make this our temp secret. It expires in a year. I'll go ahead and select add. Now, once this secret's been created, it's only going to be shown this one time. So if I leave the page and come back, I won't see this value again. So I want to make sure that I copy this now, and I'll come over to our app, and I'll put the secret in just like that. Now, the last thing I need is a user that I want to grab the email for. So let's go find a user. So I'm going to do that by coming over here to our users in Azure AD. And let's grab all the email for Adele. So I'll select Adele, and I will grab their object ID, which is the unique ID for this user, and I will paste it in right here. Save our changes. Okay, so now let's go take a look at this app and let's see what happens. So what this app is going to do is it's going to first go load in some configuration settings, and then it's going to get a Microsoft Graph authenticated client. So how does this work? So I'm passing in the config. Let's take a look at this. What this Graph client is going to do is it's going to create this thing called an authorization provider, this thing right here. So we'll take a look at that in just a second. That's going to pass in the config, and it's going to take that authentication provider, pass it into the Microsoft Graph Service Client object, and that's going to create a new authenticated Graph client for us. So if I scroll up here, this is our authentication provider. So what I'm doing is I'm getting all those values that you saw just a minute ago that we were putting in our settings, and I'm specifying also the authority of where I want this to work. Now, in this case here, I'm grabbing all of the settings, all the permission scopes that have been granted for the graph.microsoft.com resource. So you saw a minute ago that we added a permission for mail.read as a static permission, and I granted administrative consent to that application. So instead of specifying all of the permission scopes for graph.microsoft.com, in this case here, I can just use the .default, and that will get all of the statically defined and consented permissions for me. The other option I could use here is, instead of putting the URL here or the URI of the resource, I could use the client ID, right? So a couple different options. So I'm creating a confidential client, passing in the authority and the secret, and then I'm getting an instance of that using this little helper library that I've defined that you can go take a look at. So here I've got my returning back the authentication provider, which is an MSAL authentication provider, and I'm using that to create an instance of a authenticated Graph service client. So then the way the code runs is that once I have this Microsoft Graph service client, I then am going to use it to get the user's endpoint, go find a specific user and grab all of their messages, and then I'm going to write out all their messages to the console. So let's go ahead and let's see this run in action. So I'll open this up, and let's just clear this, and we'll say .NET run. And we can see that it worked. So what this did is we have our hello world, was just a little default text that we put at the top. And after it authenticated and obtained an access token, it used Microsoft Graph to go fetch all of the emails for the specified user. And it's doing that by reaching out to this specific endpoint. So /users going to a specific user ID, and then passing in, and then going to the messages endpoint. And we're seeing all these different messages. So in this demo, what you learned is how to create apps that obtain tokens without any user interaction to either act on behalf of a user or to perform tasks using the app's identity. In this case here, you notice that we didn't have the user log in. We granted an application permission, which granted the permission consent for all users in the app, which allowed the app to reach in and grab those users. So it's acting almost like a Windows service or a Daemon based app that has no user interaction. Now, unlike the scenario covered in the previous unit or in the previous section, the app doesn't need to sign in to obtain an authorization code. During the Azure AD application registration process, you can create an SSL certificate, private-public key pair. The public certificate is registered with our Azure AD app within the service or the Daemon app, and the private certificate is used to sign a JWT or JOT token that is then sent to the token endpoint. Administrators can also use a client secret instead of a certificate, but this is not required or recommended for production. Thank you very much for watching this module. I hope you got a lot out of understanding the different application types that you can create with Microsoft Identity. This was just covering the three main application types. There are additional options as well. I recommend that you take a look at the documentation for Azure AD to learn more. Thanks a lot.